Hello everybody and welcome to another video of Data Analytics, Programming for Data Analytics 621. That's the name of the course officially, which is why we're so focused on Python, by the way. So last time we actually were just writing some code to make a three-dimensional array per se, or object. And we did it. We were printing it out in different ways. In fact, here, let me just run this. So you can see, we decided that, because it's kind of hard to visualize a three-dimensional cube of data, because of course, if you're just looking at it in a computer, the computer is two-dimensional, right? So if you're just looking at it straight ahead, you might be like, okay, you see only two sides of it, so you can't see what's behind it. So like you can think of it like, imagine you're watching a bunch of soldiers lined up, like in formation, right? And you see the soldiers in the front, like the front row, right? And imagine that they're lined up in different levels, like in a building or without windows. You can see all the front, but you can't see who's behind, right? You could kind of look to the side or rotate your image, or like looking around and seeing who's over here and here, but it's not a very easy way to do it. So what we said is, why don't we just basically flatten the image out by, saying this is the first sort of front layer of that front row, then we got the second row, and then we got the third row, and so on. In this case, we only got three of them, right? And so that's basically what we were doing. And so we took something that was like this as a cube. In fact, I think at some point I drew a cube. Yeah, so we have, I didn't quite draw a really nice looking one, but I can go ahead and do that really fast. So let's just go ahead and draw what that actually would look like, a cube of data. So suppose that we have something like this. It doesn't have to be a cube, but usually it would be like a cube. So let's just say we have this, right? Or maybe just this, so it's not square. Oh wait, no, now I made it really square. So here, like this. That's not square. Okay. Just to make it different, right? And so what I'm saying is, what this data would look like if you try to visualize it in 3D. If it was two layers, it would be something like this. And of course, if these are just numbers, let's just number stuff here. I'm not really following any pattern for these numbers. This is the same as that, so these are the same number. It's technically here too. But these numbers are different. This would be like a 5, 4, 3, 2, 1, 1, 0, right? Oh, actually, no, that one's not a 0. That would be a 5. Because, this is the same one as that one. Just like this is all the same. I hope you're kind of getting what I'm getting to here with these cubes. So they're like little cubes of data. In this case, it's just numbers, but they could be objects that contain anything. Okay, until you have those. And I could go on and color everything, but I'm just going to limit my coloring to a few. Okay. Actually, if I use different colors repeatedly, I can probably get this done quickly. So yeah, why don't we just do that? Then we have a nice and full, colorful thing. Okay. And finally, we have this one. Okay. And so the point is that you can see almost all the numbers here because we're looking at it sort of like almost like an isometric kind of view. But if you're looking at it straight ahead, you would not be able to see anything but the front row. But okay, let's say you just say, okay, well, I'll just draw things like this. Cool, you can see some of the back row, but you're still missing a couple of items. So if you flatten this out, as we had it originally, in fact, actually, here I have an idea. Let's just take this, copy, and paste it. Let's kind of break it up. So if we flatten it out, we just take the front row, so we just take that and can throw away the rest. That's the front row, right? And so that's one of the rows, and that's what you would see if you look at it straight ahead. But now if you want to see the second row, what we are only able to see from what we have right now is going to be actually here, let's just Let's just do that one over because the colors, so that I can make the colors match. So this was what the entire, there should be 3x4, so 12 numbers in there. However, we can only see a couple of the numbers. We can see that this is a 3, this is a 4, and this is a 5. And then we can see, what number is this actually? I don't know. I think, yeah, that's a 1. So we put 2 1s. So we can see this is a 1 and a 1 and a 2. But we can't see any of the other ones. And that's what I'm getting to, basically. That you're not really able to visualize that data if it's in that format. You can see that one, and you can see this one. And then I think this was gray, maybe. No, it's brown. This is the gray one. This one was brown. And finally we have what looks to be like maybe this shade or that shade. One of the two. There we go. Okay. So that's what we can see. So we are basically not able to see any of these, right? These are all mysteries. And so that's why instead of drawing some sort of cube, we just make this sort of flattened version of the cube, and you just print it out. And again, this can go up to 4 dimensions. So if you had this cube but in different times, different changes. So like, for example, this is the data at exactly 10:33 p.m., which is the time I'm recording this. And so, right now it is 10:34 p.m. It just changed. And so now it could be completely different data because these are all data coming from some sensors like water. One of you guys are working on water stuff. So you could say like, okay, the sensors are reading once per minute. So this is new data on that minute later. And so you have 4-dimensional data because you have time involved. It doesn't particularly have to be only just time related stuff, but that's just the easiest one to kind of think about. And so again, that's another thing. Try drawing all states of this cube across time. It's just going to be like a massive mess. It would be like trying to overlap the cube with like 20 iterations of itself if you're doing 20 minutes, right? It would just be like blam. Of course, here it looks nice because it's the same numbers, but like imagine they're different numbers, it just becomes a mess, more like this, right? And so that's what I'm talking about. You want to flatten things. And so if we were looking at something 3D, then you would say, okay, well, this is a time 1, and then you would say time 2, and then you would put another 2 of these. And let's just say we happen to have the same cube after 1 minute because the water values didn't change. Then you're going to look at this, right? But again, here you can actually fill these in and see the entire thing versus here where you can't see it, okay? So again, that's the concept of why we flatten things, okay? So we talked about that last time, and ultimately, even though we flatten things internally in the computer, you are actually able to store all these things in any dimension you want, but they are in a way flattened because, again, whereas it's easy for us to see something in a 2-dimension, turns out that computers like to store things in a 1-dimension. And that's because that's how memory works. Memory, you can think of, even though memory is a 2-dimensional array because you basically have your addresses, and within those addresses you have spots that you can store. If you think about memory, the way memory works is you got your big stick of RAM, and each of these are addresses numbered, so like 0 to address like 100. And then this address 100 contains 32 bits of information. So that's 32 zeros and ones. You can choose whether you want to set those to 0 or 1. That's the whole point. And that represents your data, right? So you can think of this as your row, as your columns, and you have your row. So memory itself is 2D as a whole, but the data itself is 1-dimensional, right? The data itself is just these blocks of zeros and ones in one row in 1 dimension. And so ultimately, the computer itself flattens the data to 1 dimension. And the way it does it is, in Python at least, that first piece of data is just going to contain the indices of where to go for the next dimension and so on. And only that innermost dimension is actually going to contain the data itself, which is what I show with this picture here that you can see, okay, and how that links to that and finally to that. So it's a little tricky to understand how things are kept in the computer itself, but don't bother yourself too much with that because ultimately, if it works, then you just use it and you know how to use it, but you don't need to know how a car works to the dot. You just need to know how to use the car, how to operate the car, what the limitations of the car are, so you don't push them, and maybe a couple of things to be careful about the car if something doesn't work or something. That's it. You don't need to know how internal combustion actually works and like the ratio of like the fuel to oxygen injection and mixture and all those fancy things. I don't know them, and it doesn't limit my ability to drive. An argument could be said that somebody that's really, really good at a car can drive it to its max because they know all the nitty gritty. But at the same time, I could say, well, does it really, like, do you really get that much of an advantage from that? I mean, as long as you know how to use the car and the strengths and the weaknesses of the car, the handling and all of that, then you can use the car. You don't need to know chemistry of why fuel, what is it, octane, what the chemical composition of octane is, how many carbons and hydrogen and oxygen atoms are in an octane compound, and then how that chemical reaction gets mixed with oxygen to produce carbon dioxide. You don't need to know that to be able to race a car and win the race, right? And that would be you basically using the car to its maximum. Of course, if you're trying to modify the car so that you can get an advantage, that's a different story. Then yes, you should know these things because you want to optimize that fuel to air mix so that you can get as much power from the car. Or if you're using an electric car, you want to know about how the different batteries work and lithium and all that, so you can maximize that so that you can get more mileage from the car per charge, or you can get faster speed. You need to know all these things because you want to improve the car. And yes, all the people that are building all these libraries should know that so that they can actually improve them and make them run as best as possible. Sure, but you are not doing that unless you're actually doing it. Then yes, but you are usually not doing that. You are just taking somebody else's library and applying it to your project, and you want to understand how it works so you can use it to the best of what it can offer, just like somebody would with a car. And then you leave it to the people that are making the library to worry about optimizing it for your usage. And that's kind of the ecosystem. So don't bother yourself too much. Of course, I am giving you the basics here. This is me telling you like, well, the internal combustion works, the piston squishes the fuel and that pressure makes it explode. I'm trying to tell you that because it is interesting and it is a little helpful to understand so you can use it. But I'm not going so hardcore in depth to really tell you all the stuff that happens because, again, you don't need to. It's just don't overload yourself with this when you could actually be learning things that you can use, right? You're doing a data analytics degree, not a computer science degree, so there's no purpose for you to spend time on this like super hardcore nitty-gritty stuff when you could be learning more libraries to use and more data analytics methods to use that actually would benefit you and actually be something that you can use right now. So that's why I thought it was worth spending a minute and talking about that because a lot of the times we do hand wave and sometimes we explain some things but we don't go super in depth. That's why I'm just giving you an overview so that you can use the tools effectively, but not trying to really tell you how the tools are made or what the best way to build the next future tool is. If that's the case, then do computer science degree, get that degree, go make a brand new programming language, make it the best way possible, make a brand new library. That's a whole different story, right? Okay, so going back to our actual code that we had, we kind of stopped saying this works and it prints everything out, but we're not really doing anything with the data right now. It's just printing out data. We randomly generate it by just filling it with numbers. I can also change how to randomly generate data there by just throwing in different numbers in there, because right now all I'm doing in this loop is I'm just appending a value based on the loop here. But if I change this value here to a random number, then I can randomize it, right? So like let's just say that I want to do well, I could go really fancy and do some time-based thing, but I think I will just generate a random number. And let me remember, it's been a couple of weeks since we did this, so I think you had to import random to be able to do this. I think that was a library function. So let's just try that. I think it's import random. Yeah, there we go. Okay, and so now up here, instead of putting in the value k, which is the loop, let's just generate a random number and just throw it in there. Of course, we're not seeding the random number generator. Seeding means all the random number generator does, it's not really random. Although it's just a really fancy mathematical formula that's really hard to reverse engineer, but you can do it. Especially at this level of security, it's not truly random to the point that it would be very easy to crack this. But ultimately, what you're doing is just making something pseudo-random that looks random for just general purpose usage, not for security purposes. Don't do it for security purposes, however. There's other libraries for that are actually cryptographically secure and do better at generated randomness. But there's never truly random in computers. It's just you can't. It's all math, so it has to be based on math, which means there has to be a formula to it. It can be a really fancy formula, very hard to reverse, but it's still just a formula. And if you find the formula, you cracked it basically. Okay, so ultimately here, we're just going to generate a time or generate a random number, and that the all math formulas need a number to plug in, right? You got to start with a number, and you can't start with the same number each time because otherwise the formula, being deterministic, will give you the same result. So you got to feed it a different value each time, and the easiest thing to do for computers is just to use the current time. So it just uses the current time, and that way if you run it within different times, which very difficult for you to time it exactly to run it twice, then you're going to get a different number out of that. So that by default, you don't need to do anything. It just it'll do it. So now let's just generate a random number within a range. So random dot range or rand range, yeah. And then it'll be a number from 1 to 5. Actually, 1 to 9. I just want single digits. Well, don't forget though, I believe that it does not include the stop. So the 9 is not included. So actually, let's go to tens so that it includes 1 through 9. I could include 0 actually. Yeah, why not? I'm not really trying to do anything weird with zeros. So yeah, okay. Let's just give it a run and see if it works. So we can see, yeah, a bunch of random numbers, zeros in there, but no tens because again, it doesn't include the stop. I can rerun it again and you will see that I am getting different numbers. Let's try to run it twice in the same second and see if we get the same thing. No, it runs too slow. Maybe if I run it through the terminal, I can get away with that. Okay, so sorry, I was looking at the directory. So cd desktop da621. Okay, python 15.py, python 3. Okay, so if I run it again, if I run it really fast twice, oops, I'm not running it fast enough to be able to achieve that. Sometimes in C++ it uses the second, so if you run it in the same second twice, you would get the same. But I guess that doesn't really work here. But you can see though that it is random each time. You see that? So we are getting random numbers. Okay, that's good. Just makes it more interesting. So as I said last time, one of the things that I would like to try to do is take the average of the numbers, and so we can throw that in there and just compute that. So let us go ahead and do that. So the first thing you want to do is, and this is something that I noticed that you were struggling with, and I actually want to come back to that maybe at the end of today's lecture. When I was talking about finding the digits in something like this, and I noticed that a couple of you struggle with this, be able to actually extract the numbers from a string when there's multiple of them. And so, having said that, I think that's more of a question of not that you don't know how to do it in terms of coding, but more of a question of that problem solving that you get only with practice. So don't feel bad if you struggle with that. We'll go over that a little bit to give you some hints if you're still struggling trying to do that example. But we can still think about that here. So, when I want to do the average, there's a couple of things that you got to think about. How am I going to compute the average of this? So, think back, stop back for a second and don't think about code. One of the first things that you should do when trying to solve a problem is to write the problem down. And after you write the problem down, try to solve the problem on paper and try to break down the steps into simple steps like you were talking to a child. So don't use things like, well, search for something and do this before, like that's not going to help you out. You have to break it down into simple sequential steps. Yes, there's parallel programming and whatnot. You're definitely not there yet if you're doing this kind of thing. So don't even worry about that. You have to do it in simple sequential steps. Okay. So right now, what we're trying to do is take the average of a bunch of things. And so obviously, we already know how to print each individual thing in here, which is you want to run 3 loops to get in there, right? Because when you say something like for I and DL, which is the line we have in there, DL is the name of the data structure that contains the 3D list. And so when this runs this for I, it's going to basically take each of the face of the squares here that already have a length and the width, and return that back. Okay, so it's taking each of these. So basically, it's splitting it from this cube into this set right here. Okay, so this into this 2 pair set. You're gonna get this run twice in this case, or if there was more than that, you would run that multiple times. But from there, I want to break it down again. I want to break it to get one individual row of this square. So to be able to get each row, that's another for loop. So let's say it's for j and I. Now notice that I'm passing this variable here. That's because I'm saying, okay, now that you got one square here, I want to take that square and I want to get one row of that square. So j is going to contain a row. Now that I have a row, I want to break it down even further into each individual element of that row. So I say for k and j. And why j? Because I'm passing it the row. If I pass it the square, I'm back to the same thing, or if I pass it the cube, I'm back to the same thing. Okay, so understand how this breaks down. We start out with DL being a cube, and when I say for I in that cube, I'm saying for each face or square of that cube. So if this has, if this had three layers to it, I'm saying give me that first layer, so that first square. Okay, and then I'm taking that square and saying, okay, give me the first row of that square, or give me each of those rows one at a time, starting from the first one. So that's what j is. It's a row, but it still contains a bunch of individual elements. So now I'm saying, give me each of those individual elements and just return that. So that single number. Okay. If this was a 4-dimensional thing with time, then I would have to make an outer loop. Let's just say that it was like the 4-dimensional thing was called just a d4. So I would say for I in d4. Okay, and what that would say is for this instance or for this second of this time period. You can think of it that way. Okay, so that's where these for loops are coming from. And this allows me now that k is containing, again, this is just copies of the data. You're not accessing the data manually here. You have to use a range loop for that. But now you can say in here, do whatever you want with this because you have access to the individual elements. So in my case, what am I trying to do? Okay, something as simple as average. Let's think about that for a second. So what I want to do is I want to write a bunch of steps. And this will kind of build itself to code. So step 1, and what I want to do is find average. Okay, that's the goal. I want to find the average of the data. Let me write that cleaner. Find the average. Okay? And so I want to find the average of the data. So first of all, I got to understand what average means. Again, a little kid's not going to know what average means, right? So how would I explain that? Well, finding the average means to add all numbers together. So that's kind of like step 1 of what average is. After I add all the numbers together, parallel to that, I need to do another thing, and that's I need to count all the numbers. I don't have to do that parallel, but I can do it together. But the point is that you have to do both things. It's useless to add all the numbers if you don't know how many there are. It's useless to count the numbers if you don't know what the addition is, right? So you need to count all the numbers together. You obviously need to remember what these results are, so you can then do the final operation, which is to take the sum of the numbers. So I'm going to say I'm going to store that in a value called sum. I'm going to store that in a value called count. So I'm going to take the sum and I'm going to divide it by the count, and that is going to be equal to my average. But there's a catch. Before I do this, there's one more step I want to do. And that is to say, to check if count is greater than 1. Because if it's not, then I want to stop, right? So really, I want to say, you know, if count is greater than 1, then go ahead and do this. But if not, then, you know, return an error or say you can't do the average, etc., etc. Okay? So this is good enough to break out what average means. However, in our particular example, you know, we need to kind of specify how we're actually going to do that. I don't know what just happened to those numbers. They all got mixed up. Okay? So in our case, what we want to do is we want to say, you know, for each of the layers, and then inside of that, we want to kind of say, so you know, you can consider this to be like step A1, and then we have step B1, which is going to happen for each of these. Okay, so step B1 is going to be for each row of a layer, right? Because again, we start with a cube, and now we get the face, so we get that. So a layer is going to be a square, and the row is going to be a rectangle, right? So we say for each row of that layer, and finally, for each element of that row. Okay, so you're going to run it for 3 of these times, and we're going to say increase the count by 1. That's one of the things we got to do. That's basically number 2. And then number 1 is add element value to running sum. And mathematically, how would you do that? Well, if your running sum is that, then you take the current value of sum and you add the element value. Right? So that's what we're trying to do. However, we never said what we should start the count with or what we should start the sum with. That's obvious when you think about it for you, but not for a little kid, right? And not for a computer. So the first, if anything, we should have a step 0 here. And that's create a count and set it to 0. So we want to start the count at 0. You could also just write the word start count at 0. As long as you understand that means to actually create that count. Or you can say create and start. And you also want to create and start the sum at 0. So these are very trivial steps, but you have to think that way so that you can understand the more difficult problems. Okay? So once you do this, then the code, you know, especially in Python, this for each idea it just translates, right? But forget Python for a second. Let's think to the math world, okay? There's this symbol in math. Hopefully you all remember it, right? If I have something like this, you know, let's make sure that I have my notation correctly. So I believe this is called the summation symbol. Yep, and the sigma. And let's just look at an example here. Yeah, here's one. Here's one from Wikipedia that says, let's make sure I had this right. Well, this is going to infinity. It looks like. That's that one. Let's look at another one that's a little bit nicer. Yeah, this one. Okay, this one's better. This one's not going to infinity. So this one says this was from Wikipedia, and I'll put the link to that. So this one says the summation, and then it says I equal to 3, and it says I squared, right? So when you see this in math, what does that mean? Well, that means you gotta sum all the terms going from the sort of the start, which is at the bottom. So this is kind of like your start. In fact, here, let's use some colors for that. So this is your start per se. And then you stop whenever you hit this. You know, when we're talking about limits, that becomes a variable itself. Yeah, let's not do that, but okay. But let's do one where we actually have to start and stop. And then what you do is what is inside. So whatever you see here is basically what you're supposed to do for each of those steps. So this becomes, you basically plug it in. So you start at 3, so you say 3 for I. So you're going to run this for I equals to 3, then I equals to 4, I equals to 5, and then you include, you include the last term. So you equals I equals to 6, right? So you basically plug that in there, algebra. So you say 3 cubed, 4 cubed, 5 cubed, and 6 cubed. And because this is a summation, you're going to add all the terms together. And that's going to be what is equal to. So that's going to be what? 9, 16, 25, and 36. And I think they have the answer to what that addition is there. Yeah, 86. Okay. Again, this is from Wikipedia for the summation symbol, right? And so the answer to this is 86, right? And they have the same thing for product, right? So you use the capital Pi for that. Can't really draw that one. But like if you did the same thing here where you said I equals to 3 and you said 6 and then you said I squared, this would be the equivalent of saying 3 cubed, 4 cubed, 5 cubed, 6 cubed, but instead of an addition, it becomes a multiplication, right? So what would that be equal to? Oh, well, I don't know. I have to plug that in. Let's see. 9 times 16 times 25 times 36 is equal to 129,600. I like that number. It's nice. I don't know why. Okay? So that's what that would be equal to, right? So, you know, think back to your math days, if hopefully you remember them. Of course, you know, if you're really good at math, then this will be nice. Because if you can convert your problem into this, what will be the average for this? Well, think about how you would compute the average of this thing. So to compute the average of this, you want to add them together, right? So you could say you start out with I equals to 0, and let's say you have, you know, let's say you have a certain variable of them. So I'm going to call that n of them. So you're going to go all the way to n. Now, what is n? N is your size of the list. Okay, let's think about one-dimensional list that you're trying to get the average of. So if that's all you need to do for that, then all you got to do is basically add I to that, right? And so if I say that n is equal to 3, so you have 3 items in your list, then you're just going to say 0. Oh, well, oops. Here, here you're just adding the numbers 1, 2, 3, and 4. My bad there, actually. That's not what I meant to do with this. I meant to say, okay, let's just say you have an item of 3 of these, okay? But here, in here, we are going to basically multiply I, multiply or add, let's see, no, let's use it as an indexing. Yes, sorry. So I'm trying to translate math into coding. But yeah, so let's just say that our list itself, you know, is going to be L. So L contains the following. It contains a 5, a 3, and a 2, okay? So what I'm going to do here is I'm going to say L, in that index I, we're going to take those numbers together and we're going to add them all together. And after we're done with that, I don't know if this is legal math to do, I'm going to say divide by n, okay? That's what I want to do, okay? So this feels wrong. Here, I know what to do. I'll put it like this. There we go. Now it feels much nicer, okay? So now, sure, I'm kind of cheating because I'm using those square brackets for indexing, although I bet you there's a math equivalent for that. I just don't know it. Leave it in the comments below if you know it. But yeah, so what I'm saying here is I'm going to take the index for 5, so for 0. So when it says L0, it's going to be L1 and L2, right? And so I'm basically going to add 5 plus 3 plus 2, and then I'm going to say, well, that is equal to 10, right? Yeah, 10. And then I'm going to divide it by n, which is equal to 3, right? N is equal to 3. So it's going to be 10 divided by 3. So my average is going to be approximately 3.333, repeating, right? I believe that's the symbol for repeating. So, yeah, 3.3. So, yeah, that's sort of the mathematical representation of this. So in this case, though, we have a cube. So how do we kind of nest these things? Well, you nest them the same way you would with a for loop, which is you just stack them, right? So if you want to take the average of something that is two-dimensional, then all you got to do is put another one of these things. And then make sure you use a different letter up here, because you might have it might not be a square, you know, like a 3 by 3. It could be 3 by 4 or something. So let's just call this one like n sub 2 and n sub 1. And so now what you're going to do here is you're going to take I all the way to n sub 1 and then I all the way to n sub 2. And over here, instead of taking the average of that, well, sorry, the division of that, you want to take it as a summation of that, which, because it's a square, it's length times width, then you're going to multiply them together, right? So you're going to say n1 plus n2. Let's use the same notation. I'm going to use a dot for the multiplication. Okay? And then for the internal thing here, yeah, that's all you got to do. I believe, yeah. So there you go. This will be a two-dimensional equivalent of that. And if you did 3 dimensions, just to show you right here, then all you would do at this point is n cubed, okay? Now, you might be like, well, this is weird. This multiplication right here I'm doing, I don't have to do that when I'm coding it. Sure, you don't. But then you would actually have to do 2 summations, which is kind of what we were doing. You would do 1 summation for the sum. So that's going to give you your sum. If you want to split this into like into actually what we did in code, because it's nicer, then you can, because I mean, this will work the way I set it up. I can actually, you know, when I was writing, well, I'll show you when I write the code. But when I'm writing code, you know, I don't need to keep track of the count. All I gotta do is add all the dimensions together, and that's gonna give me the count, right? But in this case, I'm doing it as I'm doing the actual summation. What the equivalent of that would be here would be to like basically have these 2 summations, and then the second summation, all you're really doing is just putting a 1 here, okay, and that's it. You just put a 1 there. So it's literally gonna be, you know, let's just say we have the following dimensions: n is equal to 3, and 1 is equal to 3. This should be n sub 3 now. And then n sub 2 is equal to 2, and n sub 3 is equal to 4. Okay? So in this case, we have what is essentially a 3 by 2. So let's just say 3 by 2 and by 4. So there's 4 layers of this. So I'm just going to put them on top of each other like this, right? So if you count how many numbers there are there, it's going to be 6 times 4, basically, right? And that's the same thing as saying 2 times 3 times 4. So that's how I got the top thing there. But if I do it this way, you know, this first row is this, you know, if I plug in those numbers, n sub 1, n sub 2, this is a 3, this is a 2, and this is a 4. So this is going to go from 0 to 3. So 0, 1, 2. Well, you got to be careful about the top number, because in summation, you know, you might include the last number, but when you're doing your loops, you might not. So, you know, you might want to fix that by doing a -1s or something like that. You can do that. But the point is, you know, if you do it to count right, this is going to run 3 times, so it's going to add 3 to this, and then that summation is going to run 2 times, so that's going to be 3 and 3, so it's going to be 6, and then this whole thing is going to run 4 times, so you're going to get that 24. Okay? So that would be the equivalent way of thinking of this. So that's a for loop. That's all a for loop is in Python, is the summation symbol in math. So just like if I gave you a math problem and said turn it into like a summation, or turn it just into a mathematical formula, that's the same critical thinking that you have to do when you're trying to take a problem in Python and solve it. It's not just like, let me just try and throw some code together and see if it works. You actually have to stop and do all this stuff by hand and then come to the solution. Now you might say, oh, okay, for the average, this is overkill. I could have finished this 5 seconds ago. And you're right, I could have finished it because I've been coding for a long time, and average is also something that is very trivial. But when you get to more complicated problems, you really need to work this out on paper to get a grasp of how it's going to work before you jump in and try to code it, because otherwise your code's going to be inefficient if it even gets worked and finished. Because sometimes you're trying to do like a massive piece of code, and you're not gonna get it right the first time. And if it's so much code, it's gonna be a pain figuring out what went wrong. So that's another very useful advice that we give people when you're learning programming in the computer science classes. You want to divide and conquer. And that's a way to approach a problem. You want to split the problem into smaller problems that are easy to resolve. And once you solve those problems, then you can combine them together with other pieces that you've solved to solve a bigger problem, okay? So if I ask you, okay, I would like to find the average of all of these data that I give you, you should first divide that data into pieces that are equal, like that are actually not equal in terms of length, but equal in terms of formatting. Take the average of those, and then once you get those subsets, then take the average of those subsets together to then finally get your big average, right? So, you gotta split the problem into like, okay, I need to split the data, I need to clean up the data, then I gotta approach and do the computations on the data, and then I gotta put everything together, right? So you divide it because then you can fix the issues at that smaller level. If you have issues with going out of bounds, or you have issues just adding things together, you solve those issues there instead of just trying to solve like, okay, half of the issues are because things are not clean, I'm also going out of bounds in this, and the math is wrong. So you got all these things together and you can just get something wrong or just crashes. That's a lot harder to figure out what to do there than to solve little pieces, okay? So now that we've done all that, it's as simple as just literally going here and doing what we did. So let's just go ahead and say sum. We're gonna put in that sum as 0. We're gonna put count 0. And now we're going to go ahead and say sum is going to be equal to sum plus the new value, which is what is in k. And then for the count, I could say count is equal to count plus 1, but I'm going to show you the other way you can do this, which is when you say plus equals 1, and that's the same thing as saying count plus 1. It's just another shorthand notation for that. So when I do that, that should compute the average. So I can go ahead and just print out the count. And for the average, remember, we want to check to make sure that a count is greater than 1, because otherwise we're dividing by 0. So then you can go ahead and say print sum divided by count. So it does the math on the fly. And we want to just say average. Here, we'll spell it out. Okay, otherwise, if if it happens to be the division by 0, then no average available or something. Whatever. Okay, so now that we run it, we can see that the count is 45. Does that make sense? Let's think about it. Well, we have what is a 3 by 3, so 3 by 3 is 9. And then we have 1, 2, 3, 4, and 5 layers. So 9 times 5 is 45, which is literally what I put there when the 1 divided by. So that's all working fine. We are getting the right count. And then, this will change every time you run it because of random numbers that you can see there. It's actually interesting how that's running, because you're seeing that the average tends to be around 4. And I can tell you why. The reason why is because of statistics, right? So like, what are we doing for the random numbers? Well, we're getting the numbers from 0 to a 9, right? And so think about that. If the numbers are from 0 to 9, and in theory, they all have the same probability of appearing, then, it's like, if I say, okay, let's split this and say, okay, You get 0, 1, 2, 3, and 4. Those are the first 5 digits, right? And then on this side you have 5, 6, 7, 8, and 9. So this is the other 5 digits. So you have 10 possible digits, right? So what's in the middle of that? Well, 0, 1, 2, 3, and 4. So 4, and then here we have 5, 6, 7, 8, 9. So it's going to be between 4 and 5. That's going to be the middle. So if I told you and said, okay, what are the odds that the number, that the number you're going to get is going to be either between 0 and 4 or between 5 and 9? Well, then you say, well, you have a 50-50 chance, right? So it turns out that because you have a 50-50 chance of getting something from 0 to 4 or getting something from 5 to 9, then that means that half the time you're going to get something less than 5, and sometimes you're going to get something greater than 4, right? And so because of that, you're going to get sort of an even distribution of numbers. And because of the even distribution of numbers, the average is going to fall around the middle. So it's going to be about 4 something. In fact, the exact middle would be 4.5, right? That would be the perfect middle between the 0 and the 9. So in this case, we're getting 4.42. So that's pretty close. And the more we run this, you're going to get something. I mean, in theory, yes, just like winning the lottery, you could get an average of 1 or an average of 9. I mean, heck, you could get a bunch of zeros in there. And then your average would actually be 0. So, but that's very unlikely. You have to run this a lot of times. Here, that's over 5. That's the first time you get something over 5. But look at that, kind of perfectly balanced. We get something over 5, and then immediately we get something under 4. So, this is kind of like a little casino that we're using here. So, but you can see that in general, if we took the average of the averages, we would see that that it would still kind of average out to 4.5. So in fact, let's do that. Why not? Let's go ahead and do that. Let's make this run a lot of times. Actually, we could do that, but that's more of like a function thing. But let's do it really fast. We can do it quickly. I just have to literally put all of this code. So let's take, again, here, analysis. What do we want to do? How we want to do it? And then let's do it. Again, I could go in right now and do it because it's something simple. But even if it's something complicated, even I have to sit down and actually write this on paper before I do it. So right now we have what I'm going to say X. And X is basically the process that we have tried and tested, divide and conquer. We have tried and tested will work for finding the average of this cube. Okay? So if I say, okay, what I want to do is find the average of the average. And what I mean by this is I'm going to run this 100 times. So I want to run 100 times the generation of the number and after I run it 100 times, then do X, right? Because X is doing that computation. Okay? So you write this down, and what this means is that run 100 times is a for loop, right? So we're going to do for 100 times, for I in range of 100, or just run it 100 times, and every time you do that, you compute this. However, what variables do we need? Well, we need to have an average that keeps track of the ongoing averages, and then of course we know it's going to be 100 times, so we don't need to keep track of the count because it'll be 100 times. So we need to keep something called average sum, or whatever you want to call it. I'm going to call it average sum. And that's going to start out with an average, which it would be nice if we have to put something for the initial average. And, we could do a 0 because then that's not going to modify because we know we have to divide by 100, right? So we initialize this as 0, and every time we compute the average in X, so right beneath this, we're going to update average sum with whatever the current average from X is. We'll update it with whatever we currently have on average sum plus the new value that we get from the average here. Okay? So that's what we got to do. We got to do an outer loop, and then we got to basically just run the entire code there 100 times. So now that we process that, we can do it. So I'm going to go ahead and just take the entire code, and I'm going to press tab once, so that at the top I can write my loop. So I'm going to say for I in range of 100. It's going to run 100 times. And before I got to do my average sum, started at 0. And now all I got to do is at the bottom here, before it iterates again, so it goes to the next pass, I need to update that. So I need to put average sum plus equals the current average, which we didn't store it anywhere because we have it as sum as count. So I can just go ahead and just take that and actually put it in. I could have also stored it in the variable up here and then done it, but yeah, we'll do it that way. Okay, and then finally, after all this is done, I want to go ahead and print it out. So I want to say the sum, the average sum, probably has a better math term, for 100 times is sum of, so the average of the average, that's what I meant. The average of average 100 times is, and then what is that going to be? Well, that's going to be average sum divided by 100. And this is running 100 times because it's running from 0 to that, right? This I, by the way, you might be asking, well, is that I going to cause problems with this I? And that's not the case because this I is going to basically be on top of this one. But if you want to be extra safe, you know, you can use something else here. It doesn't really matter what you use. It's just we're not using that variable in anything. So you can say for x. You don't really keep track of that. I mean, I can, you know, I can actually use it here. Let's just say at the top, say run, and then just put it. So like run 1, run 2, run 3, and so on. Because we don't want to say run 0 because it doesn't sound as cool. We'll say run 1. And that way it'll start from 1 to 100 instead of going from 0 to 99. Okay, so it's going to be a lot of printing because we'll see how long this takes to print. The running is going to be super fast. This will be done immediately. Before I finish clicking the button, it's done. What takes long is the printing part. So we'll see what happens. Ready? And run. Okay. We can scroll up and see like tons of these. So let's just look at a couple. So here's a run. This was run 96. So we got a bunch of numbers. We can see that the average was 4.9. Run 97. We get different numbers. And we can see that the average of those was 4.2. Run 98. We get different numbers as well. They are different, right? So 571 and 598, yeah, and so on. So what is the average of the averages? That should be really close to 5, or sorry, 4.5. And you can see that it is. Look at how close is that? Almost 4.5, which would be the perfect. In theory, if I run this like a really, really large amount of times, this should really get close to 4.5, like super, super close. So let's try, instead of going from 100 to 1,000. Right? But I don't want to have to be changing this number here like every single time. So why don't we go ahead and just make a variable that the user can enter at runtime? So we can say, remember our input function? So we're going to say number of runs is going to be the input, and the user is going to be asked, enter how many runs to do. Okay? And so now in here, instead of saying 100, we're going to say number of runs. And then we can also take that same value here so we don't have to hard code it. Number of runs. And similarly here, so that the output looks nice, we are going to add it in. Let's go with concatenation. So number of runs. However, if I do that, it's going to give me an error because this is an integer, not a string. So I need to do that casting like that. Otherwise, it'll give me an error because it's trying to put a number and a string together, and it doesn't like that. So I have to convert the number into a string. So then concatenation will work. It's just a Python thing. Okay. So now if I run it, let's try 100 again first. For x in range of numbers. Right. So when you read it in here, it's being read as a string. So let's convert it to an integer. So now we're getting like the opposite of going from int to string to int. Yeah. Okay. There we go. So I just force it into an integer after I read it in. So if I do 100, you can see that I get 4.5. So it's slightly over, right? Let's run it again, and this time let's do 1,000. You can see it's taking a while this time. See, 4.506. So that's pretty good. If I go really higher than this, it's going to take forever to run. What I can do to make it run faster is I can disable the printing of the square, because then that way it'll run faster. So I'm going to go ahead and do that just so that that I can run it with a bigger number. Okay, and then we'll re-enable it later. So let's do 1,000. Oh, sorry. Let's do 1,000 again just to see how quickly it is now. I also want to comment out the prints as well for the count. Comment this one out. Comment this one out. Actually, no. Well, I do want to leave my check because I don't want to do the division if there's a 0. Actually, you know what? So the way I would do that is, you know, I can go ahead and say like a pass here or something. But the way I have the code is already unsafe because I'm doing the division here anyways. But so if it crashes, it'll be because of that. That'd be kind of cool if you see that example happen. I really doubt it. But you would probably want to put this in an if statement and then not do the division, you know? So put this in that same if statement here. Yeah, let's do that. Why not? Let's be safe. But what I do want to, if this actually does happen, I want to see it. So print, like you won the lottery. Because like the odds of that are so low that like I want to see that if it happens, okay? All right, so let's run it one more time, this time with 1,000. You can see it's much faster now. One more thing I got to comment on is this run. All this I/O is called input-output is what slows down the program because the program kind of sends a message to the screen and then waits a little bit. You can see now it's much, much faster than before. You can see just bam, 1,000 finished. Whereas before it was like, it took a couple of seconds if you rewind the video. So now let's go into 10,000. And boom, done. 10,000, 4.49. Huh, I was expecting it to be 4.500 something. But interestingly enough, it did not take, it took a, let's go hardcore. All right, that's gonna take probably a couple of seconds. If, well, I'd say 10 seconds approximately. There we go. 4.49, interesting. So we were still more accurate before in this run. Like I felt. That's like, well, no, actually no, because this is actually really close. This is 0.002 close to the perfect half, whereas this one is actually this one's actually less than 0.001. So, but yeah, so you can see that statistically this is always going to be there. Whereas if I do something really tiny, like just 1, you know, this is a little bit further away. So. Cool statistics thing right there. Very fun. Very nice. Okay. So we got a little bit excited and carried away there. Let's go ahead and re-enable our prints just to have them. And then let's just run this again. But oh yeah, we also want this one as well. Let's run it with like 10, so because we know it's going to take longer right now. So the prints, see, it took a while just for 10, but and you can see that's pretty not close to the 4.5. But yeah, you know, this is kind of nice code. I'll at some point at the end of the whole session, I will upload those examples if you want to play with them. But yeah, okay. So hopefully this is some good practice of using the 3D arrays, which is what I really wanted to get to today. The other thing that I wanted to do with the breaking continuous audio here. Now this video is going to be a little bit longer than regular. That's okay, not to worry, because some of the other videos have been shorter, and I do want to get to some of these things done. So let's talk about this. Let's talk about this issue that some people had and how to approach this. I'm not going to give you the solution, but I want, you know, if you're still struggling with this, I want to kind of break it down for you, okay? So I'll switch over to the iPad in a second, but let me copy that down, okay? So let me copy the word A24 car 31. Okay, that's the one we're trying to. In fact, I'll do a bigger example based off of that. So maybe like potato 48A. Okay, so we are trying again to find, of course, this is part of a bigger list, but you can use for loop through each word. That most people understand. The question is, when we're looking at this string, how can we take all of the numbers that are together, so all the adjacent numbers like this, and maybe make one of these 3 digits just to make it different. How can we take these numbers and extract them into a brand new list? Or basically, well, we don't know. Just the simple thing that I said is, I would like you to take the numbers in here and add them together to get the average. Okay? But if the numbers and I want to combine the numbers that are together, adjacent, so like 2, 4, 4 are together, and 3, 1 is together, but 2, 4, 4 and 3, 1 are not together because there's the word car in between. There's letters in between. So numbers that have letters in between are considered separate. Numbers that are together are considered to be, well, together. It's as combined. So like if we have something like this here, this is a number and then this is a number, but they're not combined. And I show you how to do it if we just combine them all. So if this becomes one really big number that says like 2,443,000, well actually no, 24,431,484. If we do something like that, I show you how to do that. Not a problem. The tricky part is trying to do this. So how do we approach this? Again, do not start coding. Do not start coding. If you start coding, you're going to screw things up. It's not going to go well, especially if you're fresh at this. You want to develop the algorithm, the approach at doing this, how you're going to do it. And you want to do it at a step that is actually simple. Not like, hey, okay, find all the numbers that are together and put them together and find the numbers that are separate and put them separate. You can say something like that, but that's not something that's going to translate into code because, like, if you try to explain to a kid, they would be like, well, I found a number. I found 244. I'm done. You're like, no, there's more numbers left. Well, you never said find like everything. And if you said find all, the word all is kind of like shorthand for like potentially searching things for like long time. So you can't take those kind of shortcuts when you're trying to develop these things. You have to look at it individually. So the first thing is, let's do it sequentially. So what I want to do is I want to analyze the string from beginning to end and look at each individual character. A character is going to be a number, it's going to be a letter, it's going to be something non-numeric, non-alphanumeric, right? But for now, we are only interested in the numbers. So what is the right terminology for a number? Well, it's whether it's a digit or not. So if it's a digit, okay? So we need to check whether each of these characters is a digit or not. And based on that decision, we can go on, okay? But that's the first thing that we have to understand. The second thing is that what we're trying to do is we're trying to count how many of these things there are. So write that down. We need to count the number of numbers. Okay, so how many of them there are, and we store them in a count. And we also need to add them together so that we can do the average later on, right? So we need to sum them together. Here's some of the challenges that we're going to have to face. First of all, we don't know whether the next character is going to be a number or a letter, which is going to affect how we handle things. We also don't know if the last character of the string is a number of a letter, so that's something that we also have to keep in track. We also don't know if there are no letters at all, or if there's no numbers at all. So there could be one set of numbers, there could be a million set of numbers, or there could be none. Okay, so these are all challenges that we have to keep in track so that we can work with those issues ahead of time before we run into them. Okay, so we know that we want to iterate through each of these to process them, and we know that we can do that in programming with a loop, right? You can say for each character in this string, go ahead and do that. That's not the hard part. The hard part is how we remember. We're going to have to keep memory, right? Because as we go through each of these things, if we look at this 2, when we go and look at the 4, we have to remember that this 2 was here so that we can combine it, right? Because if we see a number, so like if we see a 3, how do we know that the number before was not the character before was not a number that we got to combine, right? We don't know that, so we have to remember. So how are we going to remember? How are we going to bring this concept of memory within the loop? Well, we keep a variable, right? Just like we were doing with count and sum. Count is memory, right? Count keeps track of how many things we've seen. It's memory in the sense that you actually remember this as you're going through each of the iterations, right? Because remember, in a for loop, when you're writing in Python and saying like for I in J, the code that's run here is run X amount of times based on how many things there are in J, and every iteration that you run, it forgets what's inside. It's like it's got amnesia, okay? So if I go in here in this for loop and I create a variable called count, and I say count's gonna have a 5, and then I'm going to go ahead and say count plus plus, or actually no, let's just say that you initialize it to 0, and then you do some code, and then you because you want to increase it by 1, you say count plus equals 1, right? So what's going to happen is you should have put your count outside, but if you put it inside, every single time this runs, it's going to reset your count to 0. So when this code finishes, your count's going to have a 1 instead of the right value, right? So it's important to sort of recognize that that's what's happening in a for loop. Each instance of the for loop is like every day you wake up and sleep. So you have it's like the movie Memento. You don't remember anything from the days before. You just remember that day. And when you go to sleep, you forget the day and you wake up the next and you go on. So in order to understand and keep track of things between different days, you have to write them down, like in the movie. So in this case, that thing you write down, it has to be something that is not as part of the loop, because otherwise you're going to overwrite it. So that's why you put this outside of the loop, right? And that's how that is your concept of memory in a loop. That's how you remember things in your loop. Is you keep variables outside that you update, okay? So both count and sum are things that are have to be there, but also you're also, because you're trying to combine these numbers together, you can do that by adding them to a new list. And in that list, you can keep a running sum of that, okay? However, while you could do a list, I'm going to go ahead and do a string, because if you remember what I was talking about the other day, when I was doing this example actually, is that a string is nothing more than a list of characters, right? So if you have the word and you iterate through it, you can see that this is just a list that would literally be like, this would be what it would look like as a list. You have your square brackets, and you would have the WORD, and they would be with little quotes, single or double, doesn't matter, and they would be with commas, right? And this would be index 0, 1, 2, and 3. So if I say, let's say this is called L for list. If I say L sub 2, then I'm going to get back the letter R, right? So that's going to give me the letter R. And so that's why you think of a string as a list. So what I'm going to do is I'm going to have my loop. So I'm going to go for each letter in my word, and I'm considering word to be this thing. If you would like a better word than the word, you can say token. That's a great term. So for each letter in the token, I like using the word my, that's kind of weird. I'm going to check whether it's a digit or not, okay? So check if it's a digit. And you can do that with the isDigit function, right? So we have two choices from there. It's a digit. It's not a digit. So you can do your control flows. Remember control flows that we talked about with if events? Those are great for trying to draw things out. So if it's a digit, let's talk about that. It doesn't really matter which of the two choices you do, but let's talk about the one on the left just because why not? Okay? So if it's a digit, then it means that you want to store it somewhere to remember, okay? So there's three scenarios that you're gonna run into when you have a digit. And this is something you have to think about. This is not something that's gonna magically come up, right? So what are the three scenarios? So scenario one is that it's the first sort of character of a string of the token. Sorry, not of the token. The other scenario is that it's in the middle, meaning that it's not the first. So I'm gonna go ahead and say it's not the first character. And finally, I want to say that within sort of the it's not the first, there's two sort of possibilities to that. One of them is that it's not the first character, but it's also not the last character. It's not the first character and it's the last character. And guess what? Thanks to me writing this down and actually fleshing it out, I've sort of detected that there's actually a fourth scenario that I really should be thinking about. Because what if happens if it's also is the first and last character, so it's a single character? That could be one possibility. Because then now it becomes sort of another option. I'm gonna call it option 0. It's the first character and not the last, right? So really, you have all of these different options that you kind of have to deal with, or at least be aware of. You may not have to write individual code for each one, but by being aware of them, you can recognize potential errors that you might have in your logic, okay? So now that I know that if it's a digit, there's all these possibilities, and of course these possibilities could also happen if there's not a digit in there, then I can start to say, okay, what I want to do is I would like to append this into another string, okay? But this string is something that I don't want to keep in the loop because it's memory. So I'm going to create a new word that's just going to have nothing in it, an empty string, okay? So now what I'm going to do as I iterate through this is I'm going to append that number into new word, okay? So if it's a digit, what I'm going to do, so now that I explained to you all of this, I can kind of shrink it out and move it out of the way. So I want to go ahead, if it's a digit, I want to append to my new word token or string, okay? That's it. That's going to be good enough for me, all right, to append it. Next, let's just get rid of this for now. Let's see what I want to do if it's not a digit. Okay, if it's not a digit, then you got to think about those 4 things that I just deleted here. Let's bring them back, actually. All right, so if it's not a digit, there's 2 things I want to do. What it means when I see not a digit, it means that I've moved on to, like, for example, right now in the beginning, it's not a digit. What do I want to do at that point? Well, if I see a not a digit, there's multiple ways that I could have reached here. One of them is that I reach from the beginning, if it was the first letter, such as the case is here. It could also be that I just finished working through some numbers and I hit a non-digit. If that's the case, then I actually want to save these numbers and add them to my ongoing sum, etc., right? Another thing that I can do is, let's say that I'm hitting a letter and the last one just happened to be another letter. If that's the case, then I just want to do nothing. So there's a lot of ways that you could do this. One of them is you could actually create another variable called previous letter, okay? You could say like, and then just store the previous letter there always at the bottom of your loop. That's one way to do this, and that would be pretty easy and simple. But I think that there's a better way of doing this, and that is, don't worry about the string itself. Worry about what you're remembering in your memory, which is what you have in your new word. Here's the thing. If you've already visited some numbers, and now you visited a letter, your new word is going to contain all those numbers you visited. So then you know that this is something that you got to convert into a real number and do the sum and count. If you're looking for it, once you do that though, you can go ahead and erase what you have in new word. When you hit another letter, you again check new word, and if it's empty, it means that you were just coming from another letter. However, if it has numbers in it, it must mean that you just finished real numbers. So then you can go ahead and compute that. Similarly, in the beginning, it'll be the same thing as if you've done another letter because new word is going to have nothing. And finally, if at the end you hit the end of the string, then if you're coming up from a letter, new word is going to be empty. However, suppose that we have the scenario where the last digits are numbers. If that's the case, you're never going to hit that. So perhaps at the end of the loop, it might be a good idea that if new word still contains numbers in it, to basically offload those and add in some. Okay? So that's the basic logic of it. But there's more to this. While it is nice to do everything together, to do the sum, the average, the extraction, etc., it's kind of violating what I told you earlier of dividing and conquer. So I want you to stop for a second and say, do you really need to calculate the sum? Do you really need to calculate the average right now? Those are things that you know how to do because we've been doing them before in other examples. The hard part here is extracting the numbers. So how about we just forget about sum and count and just try to make a list that contains all the numbers, because then we know we already divided and conquered that problem. We know how to take a list of numbers and add it together and do the average, right? Just run it through a for loop, run your count, run your sum, do the division, bam, you're done. So the divide and conquer approach here is going to be forget the sum, forget the average. Let's just make the piece of code that's going to end up giving us a list of numbers. And then we can go ahead and do the sum and average and all that stuff there. Okay? So let us go ahead and do that. Again, I'm not going to do the full code, but I'm going to just write what is kind of like a pseudo code of this. Okay? So, all right. So now that we kind of developed the problem, the first thing we're going to do, step one is going to be, again, go for each character. We're going to call it X in token. We're going to call that T, or T for token. Okay? So for each character X in token. So X is going to represent the character that we're looking at in the string. So it's going to be this. And then let me bring this down too so that I can reference it. Okay? So that's my iteration, right? So again, if it's a digit, I'm going to, and I guess also, I'm going to call step 0 is I'm going to initialize my new word. So I'm going to say new word is going to just be empty for at the beginning. And I'm also going to initialize another thing. I'm going to initialize a list that is going to contain all the numbers after I figure out that they're numbers. Because that's going to be my long-term memory because that's what I'm going to do the actual sum and average of when I'm finished with all this. So I'm going to call that like step 02, and I'm just going to call that number list. And again, I'm just going to make an empty number list, okay? So now, for each of these characters in a token, if it's a digit, then I'm going to go ahead and append it to new list. Okay, so just take whatever you have in new list and append it. You know how to do that. Plus equals or numlist equals numlist plus the character, which is X. Okay, if it's a digit, that's all I'm going to do. Okay, if it's not a digit, so that's my else, then I have to do different checks, right? So I have to do another if statement there. So just so I can gain some space, let me actually make this line not vertical, something like that. It's okay. So this is a not digit. So this is check if digit. So I'm going to hit check if X is a digit. And this is my yes, it is a digit. And my no, not digit. Okay? So from there, I'm going to have another check. Okay? So if it's not a digit, I want to check if I've been building a digit along. So if the last thing that I looked at has been digit, so I've been building it along. Where do I check that? In new list. So I check is new list empty. Okay? If it is, I'm going to put the yes on this side just for space purposes. Then you can just say do nothing. Pass, whatever. Okay? Because if it's empty, it means that the last letter I must have looked at was a letter, so nothing to worry about. Or the last character I looked at was a letter. If it's not empty, that means that I just came off of a number. So I came off of like, if I'm looking at a P and there's 3, 1 in new list, it means I just came off a number. So if it's a new list, then I'm going to go ahead and do the following. First, well, here in summary, what I'm going to do is I'm going to add new list to my num list, right? But that's not atomic. That's not like small enough that we know what to do because there's a couple of steps that we have to do. Remember, new list is a string because this whole thing is made of characters. We need to take those strings of numbers and convert them into an actual integer, right? Because otherwise we'll have to do that later on and it's a pain. So let's go ahead and do that. So I'm going to say step 1 is convert the contents of new list to integer. And we know we can do that with the casting. This one I'll give you the line of code because you're still kind of fresh when you do casting, but you just do int new list. Okay, and then just store that somewhere temporarily. So I'm gonna call that like variable v. Okay, so that's the first thing I do. So I want to convert it, and then the next thing I want to do is I want to append it to my number list. Okay, so that is me appending it to the number list up here. the one that's empty. All right. So that basically handles this side. And the other one handles the other side. There's one more thing I want to do though on here. Because here's the thing. After I finish appending it, and now I'm only appending it because I am looking at a character at this point that is not a number, right? So I want to make sure that I don't append it twice because like, okay, here's what's going to happen. I look here, A, look 244, and when I get to the C, I want to append 244 to the number list. If I look at the A, that's also a digit. So then I'm like, well, I got to append what's in new list, which is 244. So now I'm appending it again, so I'm getting duplicates. So I got to make sure that after I append it once, I delete it so that I don't, it's like Memento when you erase things so he doesn't remember things he doesn't want to, so that you don't accidentally do it twice. So there is one more step here that's very important, and this is the kind of stuff you figure out because you're doing it on hand, by hand, and that is set new list to nothing, right? To delete it out. Very important you do that. Okay, this is almost done, but there is a situation here that we have not accounted for. Okay, I mentioned it, but we haven't accounted for. But before we get there, let's actually let's see if what we have so far will work. Okay, so what I'm going to do is I'm going to zoom out like this, just so you can see the entire process. Does not let me zoom out further unless I hold it with my hand. So let me just hold it, I guess. Well, actually, we'll just move up and down. Okay, but I do want to make the numbers themselves bigger so that you can see it better since I'm zoomed out. Ooh, that's a little bit too big. Okay, that's as big as I can get it without it cutting it off. Okay, so what I'm going to do is I'm going to go through this, and this is something you should do. So once you develop your initial algorithm and you think it's right, and like I said, this is almost right. There is one thing missing, but you'll see how me doing this will catch that. So you think you got your algorithm right, you got your control flow, it seems okay, you think you're almost ready to get this into actual code. What you want to do at that point is you want to take some examples, obviously pick something simple, try to pick examples that sort of cover all of your cases. And that's also hard to think about, but with time again, you try to think of things like, well, what if numbers come first? What if they come at the end? What if there's no numbers? What if there's all numbers? What if it's just one massive number? You think about all of those sort of scenarios so that you try to be exhaustive about all the possible edge cases that you'll find. And those are called edge cases because they're things that don't happen often, but when they do, you definitely want to be prepared for them so you don't run into a problem, okay? So we're going to look at this A, and we are going to essentially, start it out. So we say, okay, we're looking at the A. So for each character X, so we're looking at A first and check, is that a digit? It is not a digit, so we follow this thing. So then we ask, is new list empty? Well, we just created it and it's empty, so yes. All right, do nothing. Cool. All right, move on to the next one. So now we're looking at 2. Here, let's mark it as we go. So we did this one, okay? So now we're looking at the 2. So let's do it like underline, okay? So now we look at the 2. So looking at the 2 is going to say check if X is a digit. Yes, it is. So we go here. Okay, we append to new list. All right. So here I'm going to manually have these little rectangles which are going to represent what new list currently contains and what number list. And this is also a good thing you should do. So these are going to literally represent what is happening in memory. Okay, and you're doing this by hand by putting them there. So right now they were empty, both of them. Okay, but we're going to be adding the number 2. Well, which is a string right now. Okay, cool. All right, we can move on. All right, we see the 4 now. So okay, is X a digit? Yes, it's a digit. Okay, append to new list. So append is going to just put it in there. Okay, cool. Keep going. I think you get the idea now. So we look at another 4. Google thought I was talking to it. I'm not talking to you, Google. All right. So I'm getting weird messages here. Okay, I don't know. Weird messages. Okay, sorry. Late night messaging. Okay, so all right, so we see that 4. So is 4 a digit? Yes, it is. So we add it. So nothing fancy there. This is where things will get interesting. Okay, so we get to the C. All right. So when we get to the C, we say is check if X is a digit. Is it a digit? No, it's not. So we go here. So is new list empty? New list is not empty. So therefore we go into the no. So what are we going to do? Add new list to num list. But again, that's just sort of my explanation, but I got to run through the individual steps, which are, okay, convert new list to integer in V. So I need another variable here actually called V that stores what I have. So V is going to contain 244, but now this is actually an integer versus a string. Okay, that's step one. Step two, append it to my number list. So that means throw it in number list. Okay, so I'm going to put in 244 in here. So now 244 contains that. Okay, and finally set new list to emptiness. So basically clean it up. And now there's nothing. It's just square brackets with no space in between. Make sure you don't put a space there, otherwise things break. Cool. All right, so that covers the C. Very nice. Let's go ahead and see the A. Okay, check if X is a digit. Is A a digit? No, it's not. Is new list empty? Yes, it is. So we do nothing. Okay. And so you can see that, you know, we'll do one more. So do the R. R is not a digit. Is new list empty? Yes, it is. Do nothing. So yeah, you keep going with that. Okay, here we get something interesting here. So we get to 31. So is 3 a digit? Yes, it is. Append it to the new list. So we put it here. All right, then we see the 1 is 1 a digit. Yes, append it here. Okay, very cool. Then we see the P. So with the P, we check if P is a digit. It's not. So we check if new list is empty. Is new list empty? No, it's not. There's a 3-1 in there. Okay, so we're going to go through these steps. So step 1, convert new list to integer and put it in B. So that means take B and put a 31 in there. So it still has a 244, by the way. That's important, but it's irrelevant. It's not an issue. You could have cleaned it, but you don't need to because you never access it. At this point, it's going to get replaced with the 3-1 that's actually an integer and not a string. So that's step 1. But here, the fact that we saw that though, it's good because you can visually see that the old data was there, but that we don't particularly run into problems because we're not trying to access it. We're just overriding it with the new data. Step 2, append it to the number list. So that's going to be appended here. 3-1 as an integer because we converted to an integer. And finally, erase new list. Okay, very cool. So then we keep going. So that was the P. So now we go look at the O. Is O a digit? No. Is new list empty? Yes. So do nothing. And you will see that it does nothing until you get to the 48. Then the 48 will get added to new list. And then that 48 will be then copied over to the V. And then will be appended. So now num list is going to have 244, 31, and then 48 in it. And so on. When you get to the 4 here, you know, 4 is a digit. Yes, it will be added to new list. Then you'll see the A. New list is not empty, so you add it 4 to the B, and then it'll be appended. And finally, after that A, you'll be done. And so now, number list contains a list of numbers which you can then do the average of. How you do that? Just go and do a for loop that you say for X in number list, and then add it together. Add your sum up. There's your average. Or in the case of this, just add it to the sum list that you currently have and the count list that you currently have, and so on. All right. So that part I'm not even worried about because now you know you have a simple list of numbers you can do the average of very easily. There's one catch though. This is why you want to do edge cases. This is working fine when the last character of the string is a letter. Let's just say that this A is not here. Okay. And let's just say we're coming off from the 48. So 48 is here. We see the A here, so then we copy 48 to here to make it into an integer, and then we append it here. Okay, so now this is the list that we have. And then after actually, sorry, I skipped steps here, my bad. So we append 48 here, okay? That's it. So the next step is we look at the 4. Is 4 a digit? Yes, it is, so append it to the new list. So there's a 4 there. And now we go and look and see that there's nothing left here. So the loop finishes. So your number list contains everything but that 4. That 4 is still in new list. So that's a problem, right? Because it's a problem because we never added it. So that it's an edge case. When the last character is not a number, or sorry, when the last character is a number, you run into this edge case scenario that you're not including the last set of numbers. Or actually the entire number, the entire token was just numbers, they would never have been added, right? If you have the, like, let's just say the token was 1111, you would have added to new list 1111, but you would have never added it to the number list. So the solution for that is you need to do one more check after the looping finishes to make sure that new list is empty. If it is, you're done. If it's not, then you gotta run this piece of code one last time. So what do? Exactly what I said. After the loop finishes, so this is after the loop finishes, so the loop goes from here to there. So, you know, we go from here all the way here. So after that loop finishes, what I want to do is paste that extra check again. And then put it as a if statement. So after the loop finishes, I'm going to have an if statement that checks if new list is empty. Check if new list is empty. Okay? If the and then basically that's the same check you're doing up here, right? Is new list empty? So you just gotta copy and paste the check. So again, this is the no section. So do all that for no, and for yes, do nothing. Okay? And when you do that, that will guarantee that if you do happen to end the token with a number, they will do one more check done to guarantee that new list is truly flushed out. And then you'll be good to go. And in fact, the last time you run it, you don't really need to do this set new list to empty, because you're never going to see this variable again. So you could technically optimize it by removing that, but it doesn't matter. Okay? So this is almost basically telling you the answer. Now the question is, can you convert it to code? And I think you can, because all of these are very simple instructions. Like convert, you know that's the integer casting. Append, you know that's a append function. Set is just an assignment operator. This is an if statement, you know, true or false, depending on how you write it. Whether it's to check whether the new list is empty or not, you can just check, compare it to the empty version of the list, which is just quotes, right? For loop is just a for loop. To check if something is a digit or not, I already showed you that function. It's just called isDigit. So you know how to do this, and you knew that already before even this class period. What you still have to learn, and that's a matter of practice, is taking the problem and doing what I did, which is that control flow, and understanding it and breaking it down into easy and clean steps like this. You have to make sure that those are very small steps and clean steps. You can't just, remember a long time ago I did the egg cooking thing. You can't just say to cook an egg, all you gotta do is get an egg, throw it in the pan, cook it, you're done. That doesn't tell you anything. For someone that's never cooked before, they don't even know what an egg is. So they don't even know what a refrigerator is or where the egg is found. You didn't even say anything about where they found. You said just get an egg. Like, what does that even mean? I don't know where I can find an egg. Like, what is an egg? Do I go to like Mars and get an egg there, or like where's an egg? No, you gotta be like, well, egg is found in the fridge. Well, what's a fridge? And you can keep going down further and further until you get to something that is actually clean. You have an object called fridge, then okay, you know that's in there. All right. So hopefully this long example gives you a nice overview of that problem-solving technique. Again, it's not that you can apply this exact technique to every single problem, but it's more of understanding and getting practice. So don't feel frustrated when you're trying to write code and you just don't know what to write. You know the syntax. Now you got to learn the semantics and how to use them properly. Okay? So at the end of the day, my advice to you, and that's the same advice that we give to the computer science students when they're first learning to code, is don't jump right into the code. Develop this algorithm. This is an algorithm. What you just did right now is known as an algorithm. And it's a series of steps to solve a problem. Develop this algorithm by hand. Test it like we did. Test it. Find the edge cases. Test those too. Make a robust step of instructions. Once they're really, really robust, and once you've tested and verified that they work and they're simple enough that they are explained like this, and you could literally go and tell your neighbor, your dog, or your mom, or your kids if you have kids, if you can go and tell them and explain to them what you're about to do and they understand you, obviously don't use the word int and string, use number and word or letters. If they understand you, then you know you're ready. If you got to go to somebody small and you tell them to find something and they're like, what do you mean by find? Then it's the same thing the computer's going to tell you. What do you mean by find? Sure, there's a search function in Python, but you don't need to do it for this. It's overkill. And it actually makes it more complicated looking at neighboring numbers and whatnot. You want to make things nice and clean. You do it in one pass, or you do it in multiple passes, but you go in a sequential manner. Once you have that down to that level, then the code will write itself as you do it. And you're going to save time, headaches, and frankly, it's just going to be a much better learning experience. And it's also going to help you critically. Like, that's why, people take math in school, right? Not because they're going to every day compute the differential of like something. They're not going to compute that every day. But what they're really going to be doing is critical analysis and critical thinking. That's why they take the math classes, because they want you to actually be able to think and be able to solve problems. And the best way to do that is just to really get good at it with math. Math is your workout every day to be able to actually have those problem-solving skills, right? Of course, if you're in STEM, then yes, you might actually do calculus. If you're doing machine learning, you get to use calculus. So that's pretty cool. But ultimately, that's what I'm getting to. You have to kind of get the gears going of critical thinking to be able to convert things into math. And usually, that's the intermediary step to be able to convert it into code. Okay? Sure, the more you practice, the more experience, the quicker you can do that. And yes, you can skip some steps. Again, if I'm doing the examples I'm doing in this class, I don't need to do any of this. I could have just gone and coded it. Although I have run into problems when I've given you examples where I was like, oh, this doesn't really work out well. That's because I skipped this step. So even I get into these issues. But that's not to say that I don't do this for more complicated issues, for more complicated code. I absolutely do this. The only difference is I will do it for more complicated code, whereas you have to do it right now for simple code because that's where you're at. Baby steps, right? If I tell you to compute the average of something, you don't need to figure out how to compute an average. You already know your experience. But if I tell you, like, do this Laplace transform or some higher level math, that's something you gotta be like, oh, let's take this step by step, right? So yes, as the more advanced code you write, as you progress in the advanced code you write, the breaking it down steps are not as necessary for the basic stuff, but as for the more complicated stuff. But you're not there yet, so do it for the basic stuff, okay? Get that into that good habit, because a lot of the times, the programming students, when they get to like the higher level courses, and they just think that they can just kind of write code on the fly, at some point they get burned and it sucks. So I don't want that to be you when you're writing data analytics. Break it down into tiny steps, and especially with data analytics, because like that's even like a whole meta of like, okay, I gotta clean up the data and all that stuff. That's also breaking things down. Writing plans is an awesome thing to do here, so always break it down. Okay, so hopefully that spiel got into some of you, and go back and try to finish this now, and hopefully you do a good job on it. And if not, of course, you can send me some questions my way. Leave a comment below if you're watching this in the future, it's not part of the class or something, and so on. Okay. I know that we had a lot of things promised here versus expectations versus reality kind of thing, that we were going to do other things, but that's okay, because this is more important than this. This learning what break and continue is, next video will be pretty short. We'll get that out of the way. This comprehension is actually pretty cool, but something you definitely don't want to do early on. It's far more important to learn what I showed you right now with the critical thinking. That's what you like. Learning syntax, 20% of the work. Understanding how to use it by developing an algorithm and actually taking something from the real world and converting it into code is that algorithm development. That's 80% of the work. That's where the real work is. And that's what makes a good programmer from a bad programmer, is to be able to do that. Anybody can learn how to write code and write code. But the good people are the ones that can actually do code to make them do what they want in the most efficient and clean way, and to not make those mistakes. Okay? So with that, I leave you until the next video. Take care and see you next time. Have a good day.